Okay, well, in the last class, we discussed the elements of digital communication systems. Just I will give like five minutes description about the elements of digital communication systems, what we discussed in the last class. Okay, so coming to the basic difference between the analog communication system and a digital communication system. In the digital communication system, we have this encoding step. Okay, please observe the block diagram. So we have source encoder, channel encoder, and similarly we have source decoder and channel decoder. And this encoding is in the transmitter section, and the same opposite functionality is there in the receiver section. Okay. So now, what about the input? Input is a information. Okay. So that may be either analog in nature or digital. If it is digital, there is no need of this encoding. Directly you can modulate the component. Okay. For to overcome the error detection and error correction, to attain the error detection and error correction, the channel encoding techniques are preferred. Okay. So the information source is applied to the source encoder. So what is the importance of source encoder? Source encoder converts the analog component into a code format or a binary sequence or a data sequence. Okay. And the source encoder generates the signal in the form of a data sequence, and it is a compressed component. Okay. So because you are representing the signal in the form of zeros and ones. So that's why source encoder generates compressed encoded data. Okay. Compressed encoded data, and so that it also provides, and it also provides a good efficient signal. And second thing is it eliminates the redundancy. Okay. It overcomes the problem of redundancy, unwanted component can be eliminated, redundant component or excess component can be removed by using the source encoder. So source encoder takes the input analog component and converts it into compressed data sequence or binary sequence. Okay, with little redundancy. Now that binary sequence obtained from the source encoder is applied to the channel encoder. So what this channel encoder do, and what is the importance of this? This channel encoder collects the binary sequence obtained from the source encoder, okay, and that is converted into a sequence of code words. What is a code word? Okay, so this thing we discussed in the last class. You can see. So source encoder. So what are the two things? It performs data compression, and second one is it generates the sequence, binary sequence with little redundancy. This is about the source encoder. Next, channel encoder, what it will do? It is followed by channel encoder. What is the input of the channel encoder? Output obtained from the source encoder. But what is the output of source encoder? Binary sequence. Okay, that binary sequence is collected by the channel encoder. So channel encoder ఏం చేస్తుందమ్మా మనకి? This channel encoder adds a k number of check bits. Okay, these are redundant bits added especially to overcome the problem of bit error locations. Okay, the bit errors can be identified and corrected by using the channel encoding system. Okay, so ikkada em chestundante channel encoder collects the binary sequence obtained from the source encoder and converts into sequence of code words. Code word is nothing but the combination of n number of binary data obtained from the source encoder followed by k redundant bits, followed by k redundant bits. Followed by k redundant bits. Okay, and these importance of k redundant bits are mainly to identify the bit error location and to remove the or to overcome the bit errors. Okay, so bit errors can be detected and corrected by using the channel encoder. Now, what about the performance of channel encoder depends on the amount of redundancy as well as the code rate. Okay, code rate is defined as a ratio of number of check bits to that of number of bits available in the encoded data. Okay, K by N is generally defined as code rate. Okay, so code rate defines the channel like performance of channel encoder. Now the output of channel encoder is a sequence of code words consisting of a set of N and K elements. Okay, now that is applied to the digital modulator. So digital modulator converts that code words into signal waveforms. Okay, digital modulator converts the sequence of code words into a signal waveforms. Okay, so coming to the digital modulators, the input is a digital signal because we convert it into digital. Okay, so directly you are taking the digital component, and for the digital modulator, carrier will be sinusoidal form. Okay, so that's why the parameters that will vary will be amplitude, frequency, and phase. So that's why binary digital modulators are of specifically, like you can specify it as amplitude shift keying, frequency shift keying, and phase shift keying. Now, these are the three basic types of digital modulators. So what is amplitude shift keying? Amplitude shift keying is the amplitude of sinusoidal carrier will be switched between 0 and 1. It is switched between 0 and 1 levels of the input message signal, okay, or the encoded signal. And what is frequency shift keying? The frequency of the sinusoidal carrier is switched between 0 and 1 of the input binary signal or input digital signal by maintaining the other two parameters, amplitude and phase, as constant. So the conclusion here is that always the sequence of code words are converted into signal waveforms. Okay, for example, if it is a PSK, then binary phase shift keying. So what you will do, the phase will vary. So generally, if the how many components are there, 0 and 1 levels are there. Okay, so if you are transmitting, if you want to change the phase, okay, from 0 to 1 or from 1 to 0, obviously there will be a change of 90 degrees. Okay, so if you represent, for example, if you represent 1 with sin x, then you need to represent 0 by cosine signal. Okay, so ala represent chestam kabatti what you are doing, you are rewriting 1 and 0 by sinusoidal and cosine waveforms. Ade మీరు amplitude ని change చేయాలనుకుంటున్నారు అనుకోండి, how can you change the amplitude? You can change with higher amplitude, that is 1, or with 0 amplitude, that is 0. అంటే whenever you have 1, you will get sinusoidal waveform. Whenever you the input is 0, then there is no amplitude at all. So that is the output of amplitude shift keying. Like that, the corresponding sinusoidal parameter will vary. And also I told you that binary represents the either 1 or only 1 bit is transmitted per sample. Then it is called as binary ASK, FSK, or PSK. Okay. And we have MRI techniques where n number of bits are transmitted per sample. You can transmit multiple number of bits per sample. Those are generally called as MRI techniques. We can discuss in later in the second chapter. And this is about the digital modulator. Here you should note that whenever you want to write the element importance of this, then you should note that digital modulator converts the sequence of code words into signal waveforms. Okay. Now those signal waveforms will be applied to the transmitting antenna, and the transmitting antenna transmits the signal waveforms into the channel or into atmosphere. Okay. Now in the channel we have our noise may get disturb our signal. Okay, so our signal will get corrupted by noise. Okay. So already we said, so see here, the modulator output will have one transmitting antenna that is applied to the channel. Okay, so in the channel we have if it is a digital communication, we have multiple multiple number of repeaters will be there. Multiple number of repeaters will be there here. Okay, so those repeaters, what they will do, they will equalize the input signal, mean by eliminating the noise. So how annadi we can discuss in the further classes. Okay, so ikkada meeku inkoti entante, you should remember that the output of source encoder, the output of channel encoder, and output of demodulator and output of channel decoder, it is in the form of binary data. So that's why annitiki kuda arrow, we kept an arrow for all the corresponding outputs, and we represented as a binary stream. It is in the form of binary sequence. Okay, so whether it is a sequence of code word obtained from the channel encoder, or it may be the normal binary sequence obtained from the source encoder. Okay, so the channel, and we'll have at the receiving antenna, the signal will be captured by the demodulator, and demodulator ఏం చేస్తుందంటే, it has opposite functionality to that of modulator, and the principle behind the variation, parameter variation, will be same. And if you are using amplitude shift keying modulator, then the same ASK demodulator you should use. And if you use ASK modulator, you should not prefer PSK demodulator. Okay, so the parameter which you varied will be considered as a reference. Okay, so demodulator opposite functionality ante em chestundi. So modulator, what it did, okay, so what it performed, modulator converts sequence of code words obtained from the channel encoder into waveforms kinda convert chestundi. So demodulator entante, the corresponding wave received noisy waveforms will be converted into sequence of code words. The same opposite modulator, same functionality, opposite functionality. Okay, so demodulator converts received noisy waveforms into sequence of code words. Once again, the code word is a combination of n bit and k bits. Okay, so, and the output of demodulator is fed to the channel decoder. So channel decoder, what it will do? Channel decoder removes the systematically added check bits, where you have added check bits in the channel encoder. So channel decoder, what it will do? It will remove all the systematically added check bits from the code word. If you remove like that, then obviously it will be the information sequence. That information sequence is fed to the source decoder. So source decoder converts the information sequence into the original format, original analog component. Okay, same, the source decoder functionality is opposite to source encoder, and channel decoder functionality in the receiver is opposite to that of channel encoder. So, and source decoder finally it will generate the analog component to the destination terminal. Okay, so this is what we discussed in the earlier class. And always note that the demodulator functionality is opposite to the modulator, but the principle behind the variation, parameter variation, will remain same. So channel decoder opposite functionality to channel encoder. Similarly, source decoder possesses the same opposite functionality from as that of source encoder. Okay, this portion we discussed in the earlier class. And here you should note that the performance of the whole digital communication system depends on the bit error rate. So what is bit error rate? Bit error rate, how many number of bit errors are there per second? Per second, how many number of bit errors are there? What is a bit error? For example, if the corresponding bit which you want to transmit be 0, and if you instead of 0, if you transmit 1, it will be the bit error. And instead of 0, if you transmit 1, it will also be the bit error. Okay, so like that, how many number of bit errors are there per second? That gives the if the bit errors are low, then obviously it will generate the optimum performance. Similarly, the system should possess high SNR. Okay, and similarly the demodulator decoder reconstruction should also be good. Then only you can say the performance of the corresponding digital communication system is good. Okay, so this is about the elements of digital communication system which we discussed in the last class. Now let us go through the Advantages of digital communication system. Okay, so these are the learning outcomes for the module 1. Let us go to the module 2. Okay, here we will discuss the advantages and some of the disadvantages of digital communication systems. Okay, now so after completion of this topic, you should be able to explain the advantages and disadvantages of digital communication system. Okay, now let us go through each and every point specifically. Okay, please, this is the first slide where you have 3 points regarding the advantages of digital communication. So first thing is regarding the, it has channel decoder. I think everyone is familiar with the term. Now you are familiar with the element channel decoder. So what is the importance of channel encoder and channel decoder? First, let us speak with the channel encoder. Okay, so what is the importance of channel encoder? We studied that channel encoder systematically adds some k number of check bits to the n number of n bit binary sequence. Okay, for error detection and error correction. Okay, so the best example of channel encoder is like Hamming code. Hamming code is used for error detection and error correction purpose. I think single bit error you can detect and correct. Okay, now the digital signal, because there is a channel encoder, okay, encoding system is there, the effect of noise and distortion can be reduced, and also the bit errors you can minimize. Okay, first thing is regarding the regenerative repeaters. So first and second points almost done. Here always note that the digital signal has two like already discussed, it is in the form of binary sequence consisting of 2 levels, 0 and 1. Okay, so this digital signal, once it is transmitted through the channel, once it is transmitted, so noise gets accumulated and near the amplitude. Okay, at the amplitude axis, so noise may get added. But once it is transmitted through the channel, because we have multiple number of regenerative repeaters throughout the channel path, these regenerative repeaters, what they will do, they will consider a threshold value. Okay, that threshold value is a predefined one. How you are defining that? Based on the input magnitude, based on the input signal magnitude. For example, input signal magnitude be like plus or minus 5 volts. Okay, so predefined threshold is also plus or minus 5 volts only. Okay, so if the received signal, so somewhere at the repeater, if the received signal has magnitude plus or minus 6 volts, then what amount will be the noise? That above plus 5 volts and below minus 5 volts, we can consider it as a noise. Okay, so that noise will be eliminated by the regenerative repeater. So regenerative repeater considers a threshold, and eliminates the magnitude part beyond that predefined threshold, and that is assumed as noise. Okay, so like that, here the first and second points, if you observe, here digital signal can be able, the digital communication system can be able to eliminate the noise, accumulated noise, okay, in an efficient manner, because of the presence of regenerative repeaters. So consider it as a second point. First point ఏంటంటే it has మనం ఏం చెప్తున్నాం, ఛానల్ ఎన్కోడర్ టెక్నిక్స్ ఉన్నాయని చెప్తున్నారు. ఓకే, అవేంటి? ఇట్ ఈస్ యూస్డ్ ఫర్ bit error detection and correction. అంటే number of error bits can also be reduced. Okay, so take the first and second points as in terms of noise only. Okay, so error bits can be detected and corrected by using channel encoding techniques. Adi first point. Second point ఏంటంటే because we have regenerated repeaters throughout the channel path, accumulated noise can be reduced. Adi second point. Okay, third ఏంటంటే if you let us go through the third point. Digital hardware implementation is flexible. So for example, if you want to implement some hardware circuit, okay, so hardware something you want to develop a circuit, then this digital signal is flexible while implementing the hardware instead of taking the input signal as analog. Okay, so digital hardware implementation is flexible. Okay, and so that it is comfortable instead of considering the input as analog signal. Okay, so if you take the PC, you are just simply pressing A, B, C, D, all the alphabets. Okay, so like you are doing 0 and 1 key, like key. What so that the hardware implementation using the digital signal is easy instead of continuous variations provided by the analog signal. So that what is the third advantage? Digital hardware implementation is flexible. So that's why digital communication plays a key role in communications. Okay, this is about the third advantage. So what is the first advantage? Digital signal has, like it being a binary sequence, it has two levels, 0 and 1, and because it has channel encoding technique. Okay, because it has channel encoder, obviously it will detect and correct the error bits. Okay, so bit errors can be detected and corrected using the channel encoding and channel decoding techniques used in the communication. Second point, here we have regenerative repeaters along the channel path. So these regenerative repeaters, what they will do, it considers a threshold value and it equalizes the input the received signal, and it tries to match the received signal with the transmitted component. Okay, so next, third point, here implementation of hardware using the digital signal is flexible compared to the analog signal. Okay, these are the first three advantages. Let us move to the next slide. In the next slide, you can observe, please observe the fourth point. Here, this fourth point is regarding the source encoder. So what is a source encoder? Source encoder converts the input analog component into some binary sequence, compressed encoded data. Okay, so because the data is modified as 1 and 0, we have varieties of source encoders. Okay, so like Shannon-Fano coding method, Huffman coding, like that, so many types of source encoding techniques are there. These two are the basic level source encoding techniques, which you will study in the fourth chapter. Okay, so what the source and each and every manufacturer may utilize their own source encoding technique. Okay, so so that the strangers cannot identify the type of the source encoding technique. Okay, so so that our data is highly secure. Okay, so my point is that the data is highly secure if because of the source encoders. Okay, and please go through the fourth point. Digital signals can be coded to yield extremely low error rates. Why low error rates? Because we have channel encoders. So even though there are bit errors that can be detected and corrected by using channel encoders. Okay, high fidelity because it's highly flexible, and high fidelity, so its magnitude is constant throughout the particular interval. Okay, so if it is 1, if the magnitude level is 1, it remains same throughout the particular sample. If it is 0, it remains same. Okay, so there are no variations. And the next one is privacy. This is mainly due to the source encoding. So because you are encoding the analog data, our data will be highly secure. So strangers cannot grasp our data. So you can say the data is highly secure. Okay, so this is about the fourth point. So instead of remembering all these advantages, always keep it in mind that the additional elements in the communication system are source encoder, channel encoder in the transmitter. Okay, next regenerative repeaters in the channel, and alane channel decoder and source decoder in the receiver section. Okay, so remember these 5 terms, and you can easily write down all the advantages. You can easily attempt the advantages. Okay, so fourth one is it has low error rates, high fidelity, and good privacy. Next, what is the fifth one? in this digital communication, you can interrelate the SNR with bandwidth. Okay, so this I mentioned in the brackets. Please go through that equation. C is the channel capacity. C is the channel capacity. Channel capacity is given in terms of the bandwidth and signal to noise ratio. So what is C? C is the channel capacity. It is represented in terms of bandwidth and SNR. In terms of bandwidth and SNR. Okay. So using this statement is generally defined as the Shannon-Hartley theorem. Okay, so you can interrelate the SNR with bandwidth. So actually the digital signal possesses higher bandwidth. That is the drawback. Okay, so to overcome so you need to provide a trade-off between the bandwidth and SNR. That trade-off you can provide using the Shannon-Hartley theorem. Okay, so you may get it out why there is why we need a interrelation between SNR and bandwidth. Okay, so always you need to improve the SNR. Okay, so once you want to improve the SNR, what should be the bandwidth? So that's why you need a relation between the SNR and bandwidth. Here Shannon-Hartley theorem. C channel is defines the channel capacity C in terms of bandwidth and SNR. Okay, so digital communication is more efficient in realizing the exchange of SNR for bandwidth, which is stated by Shannon-Hartley theorem. Okay, the derivation for this you will you can study. You will study in the fourth chapter, part B. Okay, next. So, Oksari, please recollect the thing what you studied in the analog communication. So, there you studied that all the analog modulation techniques like amplitude modulation, frequency modulation, and phase modulation makes use of frequency division multiplexing at FDM as a transmission technique. So, what is FDM and what is TDM? So can any one of you define what is FDM? Did any one of you remember what is FDM and TDM? Any one of you?
Frequency division multiplexing, ma'am.
Okay, what is? Can you define? So no problem.
For a certain time width, the total frequency band is available for us, ma'am.
Is it time division multiplexing?
No, ma'am. For a certain time limit, total frequency band is available for us, ma'am.
Okay, that is
frequency division multiplexing, ma'am.
What is TDM? What is TDM?
Time, sorry, ma'am.
Opposite pair. Okay. No problem. Very good, because you remember that at least the terminology. So we are happy for that. Okay. So what is frequency division multiplexing? So very good, Amma. What is frequency division multiplexing? So it is a multiplexing ante it is a process of transmitting multiple number of message signals. Multiple number of message signals are transmitted through a single channel by dividing the number of input message signals in terms of frequency. Okay, so frequency ni divide chestaru, but the entire like for example 10 kilohertz to 20 kilohertz. Similarly 22 manaki, for example, if you take AM broadcasting, the range is from 540 to 1650. Okay, so if you separate with a and the maximum frequency division is 5 kilohertz. So bandwidth ఎంత అవుతుంది 10. So already when you discuss చేసినవే మనం. Okay, so 10 variation అంటే 540 to 550. So that is one frequency band. 550 to 560, that is another frequency band. 560 to 570, 570 to 580. So like that, the bandwidth is 10 kilohertz. Okay, so in AM broadcasting, if you see, that is an application of analog communication. Okay, so what they did, they divided and they took, let us see, n number of message signals are transmitted. Capital N number of message signals are transmitted through a single channel. What they are doing, they are dividing the frequency, the entire frequency into several bands. But that particular band is given to the user one for the whole time interval. whether he utilizes or not, but that band is given to the user 1 for the whole time interval. Similarly, user 2 is given to with the second band for the whole time, user 3 for the whole time, third band, user 4. Like that, the entire the input signals are divided, are given with individually frequency bands. Okay, frequency is divided, but that is applied for the whole time interval. Okay, and all the analog communication techniques utilize analog modulation techniques, especially utilizes frequency division multiplexing as a transmission technique. Okay, but coming to the digital signal, all these digital signals utilizes time division multiplexing, because in the case of time division multiplexing, here for example capital N number of users are there. Okay, so first user is given with entire frequency band for the time slot 1, and for the time slot 2 like a whole band will be given to him. For the time slot 3, whole band will be given to him. Like that, you are dividing the time slots. You are dividing the time into specific slots, but the frequency remains same. And the entire band will be given to the user 1 for the time T1. For the time T2, user 2 will be given with the entire frequency band. So like that, time division multiplexing, time will be divided. So multiplexing done on the time division. Okay, so by maintaining the frequency band as constant. So, and one more thing is, another type of multiplexing is also there, that is called as code division multiplexing. So instead of frequency, time, here the code format is divided. Okay, so user 1 will be given with first code, user 2 second code, user 3 third code, like that. So code division multiplexing. But my encode chestna you are representing in the form of ones and zeros. Okay, so you are like mean that you are encoding the data. Okay, so code division multiplexing, sometimes instead of frequency like time, code will also be divided. Okay, user 1 will be given with first code, user 2 another code, user 3 another code, and maintaining frequency and time as constant. Okay, so particular frequency band, particular time slot, one particular user. So like that. Okay, so anyhow, that code division multiplexing you won't study here. Just in this subject you will read time division multiplexing. So mere code division multiplexing eppudante mobile communications I think you will study, and satellite communications you will study code division multiplexing. So here you should note that all the digital communication or digital modulation techniques prefer time division multiplexing as a transmission technique. Okay, so and here sixth point is that it is easier and more efficient to multiplex several digital signals using TDM. Okay, so TDM generates efficient signal if we have proper synchronization. If we have proper synchronization between the transmitter and receiver, TDM gives the efficient result. Okay, and I think you know the main drawback of FDM. FDM circuit is complex. For example, if you have capital N number of users, you need n number of modulators at the transmitter, n number of demodulators at the receivers, 2n number of low pass filters, 2n number of band pass filters, and similarly like 2 carrier supplies you require. Okay, so like the circuit is complex and expensive. But what about the time division multiplexing? It has only commutator switch, decommutator switch, and there should be proper timing synchronization. Okay, so proper timing synchronization unte, obviously you will get efficient result. Okay, so this is about the sixth point. Okay, now let us go move to the next advantages. And storage is easy because you are representing in the form of encoded data. Okay, like zeros and ones, you can store it effective manner, and it is storage of encoded data is easy. Okay, so that is the seventh point. Digital signal storage is relatively easy and inexpensive compared to the analog component. Okay, similarly 8th point, go through that. So at the receiver like a recovery rate of the digital message is more compared to that of analog message because of the presence of repeaters in the channel. So because we are using repeaters, every time the repeaters will regenerate the input encoded data. So ala regenerate cheyadam valla, so you can reduce the losses. You can reduce the losses and you can generate the signal without any deterioration or without any loss. Okay, so data recovery is good in the case of digital communication compared to analog communication. That is the 8th one. And let us move to the 9th. So obviously this point is familiar to all of us. So what happens to the cost of digital hardware? If you take about the take the example as mobile. So in 1990, if you take like one, you will have 1G communication. So all analog modulation techniques they used, and all the 2G, 3G, and 4G upgraded communications, the cost gradually reduces. Okay, from the past decades, if you observe, cost of the digital hardware gradually reduces. For example, if you take for every 2 to 3 years, the cost reduces to half, but its performance doubles. Okay, so that is the advantage of digital system over analog. So cost reduces to half for the period of 2 to 3 years, and for the same period, the performance doubles. Okay, that is the advantage. Similarly, you can list out more number of advantages, but I have concluded to the important points and almost all cover chesanu. You can go through internet, you can find a few more. But anni kuda like group cheste, you will get these 9 to 10 points only. Okay, and so these are the advantages of digital communication over analog. So like any other system, it too have some drawbacks. Let us move to the drawbacks. So what are the drawbacks? So now I want to ask you one question. So what is the bandwidth of a digital signal? Can any one of you tell me what is the bandwidth of digital signal? You can also tell the difference between, or you can tell me what is the relation between the bandwidth of digital signal and the bandwidth of analog signal. Which one is more? What is the bandwidth of digital signal? Is it high or low compared to the analog component? Okay. You can tell. It's high. Okay, very good. Why it is high? And any idea why it is high?
Ma'am, it uses TDM, time division multiplexing.
Because of TDM? Because of TDM?
TDM వాడడం వల్ల మేము ఎంటైర్ ఫ్రీక్వెన్సీ బ్యాండ్ అంతా వాడుకోవచ్చు కదా మనం.
Entire frequency band use చేసుకోవచ్చు. Okay, that is one of the reason. And any other reasons why? Okay, digital signal has higher bandwidth. That's true. But why another? You told one reason. And any other reasons? Okay, that's good. Any other reasons? Okay, I will give you one clue. So you are converting analog signal into digital. In the last class, we discussed how to convert analog signal into digital. At least you have idea how can you digitalize or how can you represent the encoded form from the analog signal. How can you convert analog into digital? Any one of you please respond. How can we convert analog signal into digital signal? Any one of you please respond. How can we convert analog signal into digital? Cheppandamma.
By 3 steps.
Okay, 3 steps. H2 cheppamma.
Sampling.
Sampling. Very good. Quantization. And encoding. Okay, very good. By using sampling, quantization, and encoding, you can convert it into digital. Okay, very good. Now, using this point, can you say how H2? Can you say why the digital signal has high bandwidth? So, and using sampling, can you say? Telida? Okay, thank you, ma. Very good. So ikkada entante we are converting. Here we have so many reasons. Okay, still like the the research is going on. Okay, so why it is more, and here we have some like answers. Digital signal has higher bandwidth over the analog signal. That's true. Our friend told one of the reason because of utilizing the entire frequency band. That's good. Yes, we are utilizing the entire frequency band. And another point is, here you are sampling the analog component. So once you are sampling the analog component, okay, so what it will happen, you are dividing the entire time into some slots in such a way that its sampling frequency is greater than or equal to twice that of the frequency of message signal. And here the upper cutoff is getting varied. Once the upper cutoff will vary, obviously, so like you are increasing the sampling frequency, okay, in such a way that fs should be greater than or equal to 2 fm. And bandwidth is generally the difference of upper cutoff and lower cutoff. Okay, so upper cutoff minus lower cutoff ante manaki obviously the bandwidth will increase. This is one reason, ante due to sampling. As the sampling rate increases, the bandwidth will also increase. That is the second reason. And third reason entante, so we have the encoded data is in the form of 0 and 1 kadamma, or 1 and 0. For example, let us see the observe carefully the transition from 0 to 1. 0 to 1 transition avvadaniki how much time period you need? Any one of you okkasari నాకు చెప్పండి, how much time you need to move from 0 to 1? 0 to 1 మూవ్ అవడానికి ఎంత టైం తీసుకుంటారు? 1 to 0 మూవ్ అవడానికి డిజిటల్ సిగ్నల్ చూడండి అమ్మా. 0 1 ఎలా ఉంటది మనకి? డిజిటల్ సిగ్నల్ ఆల్రెడీ చూసారు కదా లాస్ట్ క్లాస్ లో.
సడన్ చేంజెస్ ఉంటాయి మేడం.
సడన్ చేంజెస్, yes, abrupt changes you will have. That abrupt change అంటే టైం పీరియడ్, అంటే ఎంత టైం పీరియడ్ లో మూవ్ అవుతుంది? ఆల్మోస్ట్ ఆల్ నెగ్లిజిబుల్ అని చెప్పొచ్చా? Can we say that within short span, almost a negligible time span, the amplitude moves from 0 to 1 and 1 to 0? Ante within that short span, ante like time interval is becoming almost all negligible. So what happens to the frequency? So it will be infinite. So almost all we can some in like some researchers will tell that digital signal will have almost all infinite bandwidth. Large and kuda will specify share it has infinite bandwidth and specify chestar, because during the sudden transition from 0 to 1 or from 1 to 0, ante within the short time interval, the frequency entavutundi manaki, frequency becomes infinite. Okay, so these are all the reasons, several reasons which lead to a conclusion that digital signal as well as digital system need large bandwidth. Ante for a digital signal to communicate, we need large amount of bandwidth. Now here you will get a doubt. If we need large bandwidth, why these equipment are constructed by using the digital component? Why nowadays everything become digital era? Because in the last slide you have seen the digital communication has provided like trade-off between the bandwidth and SNR. Okay, it has provided a trade-off between the bandwidth and SNR. Even though like a minimum bandwidth, how can be able to extract higher SNR? Okay, so that trade-off is still under research. So digital system need high amount of bandwidth. That is good. That's a drawback here. And that is that how to compensate that large bandwidth with the SNR. Okay, so that thing is still in research. Okay, so ee disadvantage ni kuda manam how to maintain trade off between the bandwidth and SNR and the channel capacity, that's going on. Okay, and that is the first disadvantage. Dani overcome chestunnaru still researchers. And second one is TDM time digital transmission is not compatible with FDM. So you cannot mingle the TDM digital transmission with the FDM, because FDM uses the analog component. Okay, here if you want to use the analog component, you need to convert it into digital first, then only you can utilize using TDM. And like direct ga mana analog component use cheyaleru. Okay, you need to convert it into encoded sequence, then only you can attain the TDM multiplexing technique. Okay, These two are the few drawbacks, but still lot of advantages compared to analog communication. So that's why what are the, at least one of you please tell me, other than H0 and H2. Okay, one of you please tell me at least one or two advantages. We have studied almost till 10 advantages and still more, you know. And please one of you tell me one or two advantages of digital communication. So with this class, we should, what is the outcome here? Each and every student should be able to list out the advantages and disadvantages of digital communication system and Japan. At least I need one or two, that is enough. Some of you please respond.
Digital hardware implementation is flexible, ma'am.
Okay, ma, very good. D8. Okay. Digital hardware implementation is flexible. That's very good. Okay. Can you tell me one more? Any other student? At least tell me one advantage. That is enough. Other than D8.
As it is containing the regenerative repeaters, it can reduce the noise.
Yes, in the channel. Okay, H1. Okay, we have regenerative repeaters throughout the channel. Okay, so these regenerative repeaters will eliminate the noise. Okay, very good, Amma. Very good. Okay, thank you, H1. Next, one more other than H1, D8. At least one advantage from your side. I'm not asking all, at least one.
Digital signal storage is relatively easy and inexpensive.
Okay, my digital. Okay, very good. It is. You can easily store the data and it is less expensive compared to the analog system. Okay, very good. G4. Okay, next. Anyone? Any additional point from other students?
No log
Ma,
during data recovery.
Entama?
No log during data recovery.
Okay. So we don't have any losses. That is also due to the regenerative repeaters. Okay, good. Like any other points from other students?
Digital communication is more efficient in realizing the exchange of SNR of bandwidth.
Okay, we can provide the trade-off between SNR and bandwidth. Okay, ఎందుకని మనకి ఇది ఎందుకు కావాలి యాక్చువల్ గా డిజిటల్ సిగ్నల్ హ్యాస్ హైయర్ బ్యాండ్విడ్త్ అని చెప్తున్నారు. సో హైయర్ బ్యాండ్విడ్త్ యూస్ చేయడం డిఫికల్ట్ కాబట్టి and we can say that we can provide like better trade-off between SNR and bandwidth. Okay, good. H7. Okay, next ma, one more student, please interact. Any other student, please? And ఇలానే కాస్ట్ గురించి మీరు చెప్పొచ్చు. కాస్ట్ will gradually reduce for every 2 to 3 years. Like along with that, performance will double. Okay.
Fidelity and privacy, ma'am.
Okay, it has very good. అది మనం మర్చిపోయాం ఏంటి, ఛానల్ ఎన్కోడింగ్ టెక్నిక్స్ ఉన్నాయి కాబట్టి so it will convert it into a sequence of code words. So that's why our data is highly secure and secure. Okay, so it has good privacy. Okay, very good. Okay, these are all the advantages. And disadvantages ఏంటంటే మెయిన్ bandwidth ఉంటుంది, higher bandwidth. To overcome that, digital communication can provide a trade-off between SNR and bandwidth. Okay, అది ఎలా ఓవర్కమ్ చేస్తామన్నది కూడా చూసారు. So these are the outcomes for the today's module. And in the next class, we can see the third module of the chapter 1, that is the elements of PCM. So what is PCM? Pulse code modulation. This pulse code modulation is one of the pulse digital modulation technique. మనం ఆల్రెడీ లాస్ట్ క్లాస్ లో చెప్పాము. ఏం చెప్పాము? There are two varieties of pulse digital modulation techniques, pulse code modulation and delta modulation అని చెప్పారు. Okay, so ఈ two techniques we'll study in the chapter 1. So in the next class we can go through the block diagram, అంటే simply to say elements of PCM. So like sampling, quantization, encoding. Okay, so next class we can distinguish all the elements present in the PCM system. So e block diagram, go through this block diagram, we can discuss in the next class. So each and every like element we need to discuss in detail. Here I can discuss about sampler, quantizer, encoder, asla how it will encode. So encode చేస్తుంది అని చెప్తున్నాం, but how that we did not complete, that will complete in the next class. And one more thing, here chudandi we have 3 blocks here. Above first top one is the transmitter section of PCM, and second row is the channel, third row is the receiving section. Okay, PCM transmitter, channel, PCM receiver. So this part we can discuss in the next class in detail. Okay, so and here in the transmission path, in the channel you can observe multiple number of regenerative repeaters. So we can discuss about these repeaters here. So as a repeater ela work chestundi, what is the circuit for that? So alane how the sampler will be, how the quantizer, how the encoder, that's all we can discuss in the further classes. Okay, and then we can complete the SNR calculation for PCM. Then we can move to delta modulation. Like that we can continue with the unit 1. So anyhow we can discuss PCM elements in the next class. Okay, any doubts from your side? Wait for few 2-3 minutes, I will take the attendance. Okay, any doubts from your side, or can we wind up the session? Any doubts you can ask, no problem. So other students you can leave. If you have no doubts regarding the advantages and disadvantages, you can leave the session and you can join the next class. I took the attendance.